गुड आफ्टरनून ऑल ऑफ यू। हमने जो है पिछले लेक्चर में सिंथेटिक एप्लीकेशन ऑफ अम्पोलम कंसेप्ट डिस्कस किया था बाय द यूज ऑफ अम्पोलम रिएजेंट 1,3-डाइथाइन। ओके, आज जो है हम सेकंड अम्पोलम रिएजेंट डिस्कस करेंगे जिसका नाम है इथिल Thio-methyl sulphoxide. Okay, this is the second umpolung reagent. Ethyl Thio-methyl sulphoxide. Okay, now look here. This is the general representation of ethyl Thio-methyl sulphoxide. Okay, this is the structure of ethyl Thio-methyl sulphoxide. Ethyl Thio-methyl sulphoxide. Okay, when we see the structure of ethyl Thio-methyl sulphoxide, here this carbon atom have a partially positive charge. Because of this carbon atom is attached with the highly electronegative species sulfur atom. Okay, here sulfur have a vacant d orbital, and on sulfur atom a negative electronic plot will be present, due to which the adjacent carbon atom of both sulfur atom become a partially positive species. Okay, after that this ethyl Thio-methyl sulphoxide treated with a base. Suppose here I am taken LDA. Okay, LDA is a base. Okay, so in presence of PHF at near about 78 degrees Celsius, a LDA extract one proton from the ethyl Thio-methyl sulphoxide. Okay, it is a base, and we know that base generally used to extract the proton, or it is used to deprotonation of the compound. Okay, so LDA extract one proton from the ethyl Thio-methyl sulphoxide. Okay, due to which the bond present in between carbon and hydrogen shifted toward the carbon atom. Okay, this bond shifted toward the carbon atom, and we will get this type of salt. Okay, when we see the salt of ethyl Thio-methyl sulphoxide, okay, the lithiated salt of ethyl Thio-methyl sulphoxide, when we see the structure of lithiated salt of ethyl Thio-methyl sulphoxide, here the umpolung is observed. Now look here, in the first structure of ethyl Thio-methyl sulphoxide, here the carbon atom of ethyl Thio-methyl sulphoxide have a partial partially positive charge. After the reaction of LDA with LDA, that carbon atom bear a negative charge species. So here umpolung is observed. We know that umpolung is nothing but the change in the polarity of carbon from partially positive to partially negative. Okay. So here umpolung is observed. Okay. So this is the ethyl thio-methyl sulphoxide. Okay. This is the second umpolung reagent, and it is mainly used to form a 1,4-dicarbonyl compound. Okay, 1,3-dithiene is generally used to form a new carbon-carbon bond, but the ethyl thio-methyl sulphoxide is generally used to form a 1,4-dicarbonyl compound. Okay. One of the most important synthetic application of ethyl thio-methyl sulphoxide is the formation of 1,4-dicarbonyl compound. Okay. We know that the dithiene lithiated salt, okay, look here, this is the structure of dithiene lithiated salt. Okay, when the dithiene lithiated salt is treated with alpha beta unsaturated carbonyl compound. Okay, this is the alpha beta unsaturated system. Okay, we know that the dithiene lithiated salt is treated with alpha beta unsaturated compound to produce a alpha hydroxy ketone. Like that. Here the dithiene lithiated salt is act as a hard base because of due to the presence of highly electronegativity sulfur atom, the electronic cloud present on the d vacant d orbital of sulfur atom. Here d vacant orbital is present on sulfur atom and negative electronic cloud is present on it, due to which the one dithiene lithiated salt acts as a hard base. Okay, and the alpha beta unsaturated carbonyl system act as a hard acid. So here hard base hard acid interaction take place and we will get a alpha hydroxy dicarbonyl compound. Alpha hydroxy carbonyl compound. Firstly, the negative charge of the lithiated salt act on a carbonyl carbon atom of alpha beta unsaturated system to get this type of intermediate product. Okay. After that, this intermediate product undergoes amalgamated hydrolysis to form a alpha hydroxy carbonyl compound. Okay, look here. This is the alpha carbon and at alpha position a hydroxyl group is present. So it is a alpha hydroxy carbonyl compound. But in the case of ethyl thio-methyl sulphoxide, the lithiated salt generated it act as a soft nucleophile. Let us see here. This is the structure of ethyl thio-methyl sulphoxide. Okay, it reacts with LDA in presence of EHL at minus 78 degrees Celsius. So here deprotonation takes place. LDA is a strong base. It extracts one proton from the ethyl thio-methyl sulphoxide, and we will get a lithiated salt of ethyl thio-methyl sulphoxide. This is the lithiated salt of ethyl thio-methyl sulphoxide. Okay. These lithiated salt act as a soft nucleophile, a soft base, and it attack on alpha beta unsaturated system to form a 1,4-dicarbonyl compound insist of alpha hydroxy carbonyl compound. Because of it act as a soft base and it attack on a beta carbon atom of alpha beta unsaturated compound insist of carbonyl compound of alpha beta unsaturated system. Okay, due to which a 1,4-dicarbonyl compound is formed insist of alpha hydroxy carbonyl compound. Look here, after the formation of lithiated salt, this lithiated salt act as a soft base and it treated with alpha beta unsaturated system. Okay, so the negative charge of the lithiated salt of ethyl thio-methyl sulphoxide attack on the beta carbon atom of alpha beta unsaturated system insist of carbonyl compound. Due to the attachment of this carbon to this carbon, the pi bond between this carbon atom and this carbon atom shifted in between this carbon and this carbon. Due to which the pi bond present in between carbon and oxygen shifted toward the oxygen, and we will get this type of intermediate product. Okay, the negative charge is bonded with this carbon atom salt with alpha beta unsaturated system to get this type of intermediate product. Okay. After the formation of this intermediate undergoes amalgamated hydrolysis Hd plus 2 in presence of water to form a 1,4 dicarbonyl compound. Here the negative charge is shifted in between oxygen and carbon due to which this pi bond shifted towards this carbon atom, and here one proton is extracted from the water molecule. So the bond between this hydrogen and carbon, oxygen shifted between oxygen and carbon, and this pi bond shifted for this carbon atom become a negative charge species and it attracts this proton to get our final product 1,4 dicarbonyl compound 1, 2, 3, 4. Okay, this is the 1,4 dicarbonyl compound. Okay, this is the important application of ethyl thio-methyl sulphoxide. Formation of 1,4 dicarbonyl compound by the reaction of lithiated salt of ethyl thio-methyl sulphoxide with the alpha beta unsaturated compound. I hope you will be understand better. If you have any problem regarded to this topic, you can ask me. Okay, after the better understanding, I am taken another example. Generally in your exam, the question will be asked like that. Complete the reaction. Complete the reaction. When we see the first reactant is ethyl thio-methyl sulphoxide. Okay, this is the ethyl thio-methyl sulphoxide. This is the second umpolung reagent. Okay, when the ethyl thio-methyl sulphoxide oxide treated with alpha beta unsaturated carbonyl compound gives a 1,4 dicarbonyl compound. Okay, so here firstly La is a strong base. It attracts the proton from the ethyl thio-methyl sulphoxide. Okay, and we will get a deprotonation product called as lithiated salt of ethyl thio-methyl sulphoxide. Okay, this is the structure of lithiated salt of ethyl thio-methyl sulphoxide. Okay, after the formation of salt, this salt treated with this alpha beta unsaturated system. Now look here, the negative charge carbon of the ethyl thio-methyl sulphoxide salt is treated with beta carbon atom of alpha beta unsaturated system instead of carbonyl compound. Because of this lithiated salt here act as a soft nucleophile. Okay, Okay, so here it attack on this beta carbon atom of alpha beta unsaturated carbonyl compound, due to which this pi bond shifted in between this carbon and this carbon, and the pi bond between oxygen and carbon shifted toward oxygen, and we will get this type of intermediate product. Look here, this is our sulfur, this is sulfur, this is oxygen, this is hydrogen, okay, and here ethyl group, okay. This negative charge is bonded with this carbon atom, okay. Okay, this negative charge is bonded with this carbon atom, and the pi bond present between this carbon and carbon shifted in between this carbon and this carbon, and this pi bond shifted toward the oxygen. So oxygen here negative charge species, and here Li is present. Okay. After the formation of this intermediate product undergoes amalgam hydrolysis to form this type of intermediate product. This is hydrogen, this is sulfur, oxygen. This contain one ethyl group, and this is the OH will be generated. Okay. After the formation of this type of intermediate product, the bond present between hydrogen and oxygen is shifted in between this carbon and oxygen. Simultaneously, the pi bond present here is shifted toward this carbon atom, and this carbon atom become a negative charge species, and this negative charge carbon species abstract this removing hydrogen proton, and to form our final product like that. Here one hydrogen is present. Here C double bond will be generated, and this carbon is bonded with this carbon atom, and here C double bond will be O is generated. Now see here, this is the 1 position, this is the 2 position, this is the 3 position, and this is the 4 position. Okay, so the main application is the formation of 1,4-dicarbonyl compound is here generated. So this is the 1,4-dicarbonyl compound. Okay, so this is all about the second umpolung reagent, ethyl thio-methyl sulphoxide. Okay, ethyl thio-methyl sulphoxide in synthetic application act as a soft nucleophile, and it attack on a soft acid alpha beta unsaturated carbonyl compound. Okay, the negative charge carbon atom of the lithiated salt generated from the ethyl thio-methyl sulphoxide is attack on beta carbon atom of alpha beta unsaturated cysteine instead of carbonyl compound, carbonyl carbon atom of carbonyl compound. Okay, due to which a 1,4-dicarbonyl compound is generated. Okay, if you have any problem, you can ask me personally.